Namaste. I am Dr. Deepak Subramani, a faculty member in the Indian Institute of Science. I am here to talk to you all about AI in government transforming public service delivery. A brief background about me. I did my BTech and MTech dual degree program from IIT Madras in 2007, graduated in 2012, and then went on to do my master's and PhD from the Massachusetts Institute of Technology, MIT, in the USA in computational engineering. I work on developing AI and ML methods for a variety of applications, including weather forecasting, ocean forecasting, autonomous underwater vehicles, computational fluid dynamics simulations, working with human elephant conflict resolution, modeling that using AI and ML, looking at delivery of education at the K-12 level using AI and how we can use generative AI technologies to improve the learning outcome of kids in high school. These are the different activities and research that I am involved in. Today, I'm going to talk to you about harnessing generative AI for smarter government. Really, the world of government and service delivery to citizens is a tale of two worlds. Right? As a citizen, we know that we have been used to looking at village office or a government office. In the old times, the past was clunky, paper based, manpower heavy, slow processes. Slowly but surely, many of the government offices are in fact now improving to sleek, digital, AI-driven, fast processes. And how can we make the transition AI-enhanced digital governance possible is the focus of my today's discussion with you all. So let's take a example. Let's imagine a patient walking into a government hospital. So he could think that, okay, this person walks in, registers at the OPD, stands in line, and then waits to see the doctor. So now, when we see the doctor would then discuss with the patient and maybe scribble something on the file, and some discussion happens. They may ask some questions, the patient responds something, and then doctor processes this information and perhaps asks for some more investigations. And then the patient moves from the outpatient department to the lab section or the imaging section, goes there, does the investigation, collects the results, then come back again, joins the line, sees the doctor, and then the doctor looks at their notes from before and the new investigation or whatever they have, whatever the patient has done, and then comes up with a revised diagnosis or some plan of action for treatment. Send the patient to the pharmacy or maybe admit, as the case may be. Right. So this is a typical workflow of a patient walking into a government hospital. Right. So this is what we all know about. Now the question is, how can we use and leverage AI to enhance the patient experience? Right? So, how can we use AI to enhance the patient experience? So, the different steps that we saw, right? So, that was a workflow of a patient entering the hospital. If we see that workflow, we could think of an AI enhanced solution as follows. When the patient walks in to the OPD. No need of standing in a huge line. A Aadhaar and facial recognition based registration process can be completed, maybe like DigiYatra, or even they just come in, their face is scanned, Aadhaar information is taken, a wristband or like a token with a QR code is issued to the patient. If they don't have a phone device, so it's QR code is issued. Then with that, they go to see the doctor. The doctor scans the QR code, and let's imagine a small device is placed on the table or close to where the doctor and the patients are interacting. And this device records the multilingual conversation that the doctor and patient could have and then transcribes it accurately and enters this information into the database of the patient, so file of the patient that is linked to the QR code. Now the instructions that the doctor gives is also linked to the QR code. The doctor says that now you go to the lab section, and the patient then walks over to the lab section, scans the QR code there, gets the necessary investigations done, and then the crowd just flows, right? So the actions are updated to the database with the QR identification, and then they come back to the doctor. And so when they come back to the doctor again scans, then sees what the scan the QR code and see what the previous doctor has seen, or the same doctor and another doctor can see. Everything is recorded cleanly and clearly, and the next steps are taken. So this will be an AI enhanced doctor in the loop workflow, which is to replace the previously manual workflow to make the patient experience better. So this will be AI enhanced or a generative AI application for a typical workflow that we see, which will enhance the delivery of medical services, which is in a government hospital setup. This is just one example, right? So how you can think about using AI. This is a use case, right? So of how to improve the patient experience. Now you might argue, right? So we know that in many government hospitals, we are very far from this kind of idealized AI enhanced workflow, right? Why? In fact, to enhance public service delivery, to transform public service delivery, there are two aspects. One is digitalization, and second is the artificial intelligence, among other aspects. So two aspects that we will focus on is digitalization and artificial intelligence. We are talking about enhancing service delivery through AI, and in many cases, this digitalization process itself might be absent, and we can do artificial intelligence only after the digitalization process has been completed in some sense. So in this case of this government hospital where the doctor, where the patient is coming to meet the doctor, in many public hospitals, the digitalization itself has not taken place. It's everything is still manual, hand recorded, handwritten. So forget about artificial intelligence being there in place. So digitalization is very important and a prerequisite for artificial intelligence to come about. So given that what I've just described, right? So in the sense of what one example, a case study of AI enhanced delivery of a public service could look like, and the issues of reaching there, the first step being digitalization, and the second step being artificial intelligence. So why are we talking about artificial intelligence now, even when digitalization perhaps has not taken place? It's because of the recent buzz in this field of AI. So what is the cause of this recent buzz in AI would be important for us to understand. So the primary reason many people are talking about artificial intelligence today is because artificial intelligence became very accessible to the public through chat interfaces with the advent of models like ChatGPT. This is what made, right? So the public aware of artificial intelligence. So several models like ChatGPT, GPT-4o, O1, and today DeepSeek, Sonnet, Gemini, these are all made the power of AI accessible. And another thing is most of these models are English language models. So, and they have very high accuracy in the generation of text that they do in the richly represented Western languages. So they're very good at speaking English. And we tend to have a feeling that if somebody speaks English well, then they must be really good. So if somebody speaks language well, it's very polished language, then their thought process must be polished, or their reasoning capabilities must be polished, and they must be very knowledgeable people, and we kind of respect them. We give respect. So that's natural for us as humans to do. And these AI models are become so accessible, and they speak English very nicely, that we kind of think that, oh, they are this all powerful being that is there to help us solve all problems. Right? That feeling kind of comes. But if you think about it, the actual use case of AI, people use AI for information retrieval. So to retrieve a piece of information that you want to know an answer of, right? So it's like question answering, or perhaps writing emails, correcting text that you have written. And so all these are the use cases that people use AI for primarily. Previously, we used to use maybe something like Google search, right? So now you use Google search enhanced with the generative AI output, right? So instead of you going and looking at some 10 links that Google search is giving you, now you can get a summary of those 10 links, right? In the form of question answering, answers to questions. And then writing emails is very easy today. Writing very beautiful emails is very easy today. You just type few words of what you want to be written in the email, and then it goes about doing that. But due to the superior language skill, especially to English as second language users, ESL means English as second language users, we tend to think that these models have achieved intelligence at the level of a human. But if you think very deeply, they are good at retrieving information, presenting information in a form that we commonly associate with intelligent human beings. So that's what these models are really capable of doing. And recently, with the AI for Bharat initiatives and the Bhashini project, we have several Indic language translation services, and excellent work is being done by research labs and startups on creating Indian language speech recognition models and speech to text and text to speech models. So, of course, Indian language is also improving. But the mostly we tend to think of AI in terms of this English based things, and that's why we give into this recent buzz in AI. But even before we go there, right, so and try to use artificial intelligence for enhancing public service delivery, let us understand what is AI, right? So, like, what do we mean when we say AI? So, let us break down things and first understand the meaning of the word that is artificial intelligence. So, we all are familiar with the movie Superstars movie, right? So, Robo Indiran in Tamil. I would say that no, if anybody has done some work, uh, popular work, to make AI or the powers of AI accessible to the public at large, it is direction. It's so through that movie. And Chitty Robo is the epitome of what we call today as artificial general intelligence. When we say AI, we typically mean a computer or a computer controlled robot that is able to perform tasks that are commonly associated with intelligent beings. This kind of a working definition of artificial intelligence that we can think about, right? So that is the ability of a digital computer or a computer controlled robot to perform tasks that are commonly associated with intelligent human beings. This is what AI stands for. Typically, these tasks could be interpreting language, it could be understanding images, it could be looking at some statements and writing what is the next, what is the reason for that statements that are being said. These are typically activities that humans are very good at doing. And there are also Hollywood movies, right? So that kind of present this idea about a artificial intelligent being as the supernatural, superhuman being that is capable of doing tasks better than humans. The point to remember is that today's artificial intelligence systems can be what is called as data driven systems or model driven or rule based systems. So data-driven systems mean that we don't explicitly say this is why you need to give a particular answer. So a question and an answer to the question follows. We don't give a specific rule that you give an answer to this question in a particular manner. I will give you a example. So let's say you go and search for what are the restaurants that are near you. Right? So now a rule-based system would go to a database, look for all the restaurants, return it, and present it in the form of a table. So that will be what a rule-based system will do, because you have searched for restaurants, right? So I must go to a database, search for restaurants, and then bring it. A data-driven AI solution, what it would have done instead would be it would have got trained on all restaurants that are near you, etc., etc. And then when you ask a question, it will start generating text, right? So saying these are all the restaurants that are near you. So that AI system is fully trained on the basis of data. These are typically language models that get trained. So these data-driven models that get trained. Or there are these model-driven systems which are rule-based systems that are in operation. This is kind of like one example. If you go further, right? So if you think about weather prediction, atmospheric ocean prediction problems, a rule-based system would be a physics-driven system, right? So I write the partial differential equations that predict the state of weather tomorrow or the amount of rain that we might get tomorrow. That would be a model-driven, rule-based system. A data-driven system would be, I don't write explicit equations that govern how rain will be. I will use last 114 years, 120 years, 125 years of data of rain, and then use that data with all causal factors, observations I will use, and develop a general purpose machine learning solution which could then predict the weather conditions of tomorrow. So that will be data-driven model. In the first case, it's a rule-based, a physics-based model. In the second case, it's a pure data-driven model. So artificial intelligence, when we are working with language technologies or vision technologies, the rule-based approaches don't work very well, as different from science applications where we kind of know the first law of motion, second law of motion, third law of motion, all these things we kind of know, and then we know that thermodynamics has some principles we know, so physics we understand, so we can build model-driven systems for scientific applications, but for socio-technical applications involving language technologies and involving images, we cannot perhaps write rule-based systems. Instead, we have to go for data-driven applications, data-driven artificial intelligence. And post 2017, right? So when the transformer architecture, one particular type of AI model was developed, which could learn from data and give you output of text, right? So that made the data-driven language technologies become very popular, and over the last 6-7 years, that popularity has skyrocketed to all the so much powerful AI models that we have today. But in some sense, all of those models are still what we call as a narrow AI, meaning they are very good at doing particular tasks like sentence completion, question answering, identifying named entities in that text that you give, or classifying of text, classifying of images. So these are very narrow tasks that this artificial intelligence system can do. They are not at the level of robo chitty, right? So which can learn from the data on the fly and act like an intelligent human being in unknown situations. So that is artificial general intelligence, which is the ultimate goal in AI research, and we are close to that AGI today, right? So today we have very good data-driven AI systems that are good at performing certain tasks like sentence completions. That's what our AI systems are all about. In that line, I was telling you that over the last 6 years, this generative AI models, so specifically transformer-based language models, have been developed. And today we have several transformer-based, transformer is a particular type of architecture, transformer-based large-scale AI models that are trained on textual, image, video data from diverse sources. These models are the well-known OpenAI's ChatGPT model, Anthropic, which is another company which has a Claude 3.5 Sonnet model. Google has Gemini Pro model. Meta, Facebook's parent company, has a model called as Llama 3. Instagram, WhatsApp, right? So their model is Llama 3. Then Twitter, right? So now called X, has a foundational model called Grok. Very recently, DeepSeek, another small company from China, they have a foundational model, right? So that is capable of doing very good reasoning. So these large scale models serves as a base for multiple downstream, these narrow tasks that I was talking to you. And these large scale models, what they are capable of doing is they have a very broad knowledge and capabilities of text. And once they have this very broad knowledge and capabilities of text, you can then perform what is called as prompt engineering to make them perform specific tasks. Then we look at issues where, when you ask a question, right? So this is called as a prompt engineering. As you ask a question to these models, you prompt the model. That model is able to give you an answer, but that answer might not be conditioned on the facts of the matter, right? So because that model has not seen the particular facts of the question that you are asking. In such cases, when you want to tap into specific data, we have to enhance our the questioning of the model through a mechanism called as retrieval augmented generation. So first we have to search for the specific data. Then use the search result of that specific data together with generation capabilities and give you a response as an answer to the question that you asked. So in these two cases, you actually don't need to develop a model from scratch, right? So you can use these existing foundational models and develop application layers on top of it. And there are several use cases where you can simply apply this application layer on top of this foundational model. And that was one of the most debated topic in recent times, is whether India should develop a foundational model of its own, or we should focus on the application layer only. So should we just look at prompt engineering, maybe retrieval augmented generation of foundation models that the West or now China has created, and then perhaps we don't need to train our model from scratch. In my opinion, we need to do both, right? So in the sense that we have to develop our own foundational models, that could be science foundational models, language foundational models, our own Indic language foundational models, all of this on one side we have to do. On the other side, we cannot wait for all our foundation models to be developed and then do application on top of it. The application time is ripe now. So we have to also invest and do application development, right? So that is on top of the foundational models that are already available through prompt engineering, retrieval augmented generation. Now, one in between thing, that is, you don't have to train a foundational model from scratch. You could use, let's say, an open source foundational model. For example, the Meta's foundational model, right? So Llama 3 foundational model is actually open source and open weight model. The ChatGPT and Sonnet, they are not open models, right? So they are closed source. So Meta has given open source. So if you have such open source models, you don't have to train a foundation model from scratch. You can use a checkpoint, that is a pre-trained Llama model, and then start fine-tuning from it for the specific data, specific tasks that you have. Now, if the base model has been trained on multilingual data, then you could then fine-tune it for some specific applications in your multilingual settings. Overall, our goal is to generalize to new tasks with minimal additional training. For that, we need some foundational model. We have to invest in developing our own foundational models, but we cannot wait till after our foundational models are developed. So we have to also look at application development. So the use case that I described to you of the patient walking into a government hospital, that has some parts that could be done using prompt engineering or retrieval augmented generation, but other parts that require our own models that will do multilingual translation applications, right? So it would be necessary to have both there. In general, base models are these foundational models which can then be tuned, or application layers can be developed on top of this foundation model to do applications like you rewrite in a different style, correct the grammar, make it follow some kind of instruction, doing question answering, summarization. So instruction following could be something like, okay, I want to write an email to my boss, and in the email I want to describe all the work that I have done in the last week, and this is the work that I have done, right? So from 5 works, whatever I have done, and this is the output that was generated from those works, and then ask the model to write that email. So that would be instruction following use case of using a Gen AI application, which people do today. So that's what this foundational model is, and different applications of this foundational model. Now the question that we are asking is, so let's quickly revise, right? So we were looking at a use case of a patient walking into a government hospital and looked at the workflow. And then we said that, how would that workflow look like? We imagined a AI enhanced workflow for that. Then we asked the question, what is artificial intelligence? Why this sudden buzz about artificial intelligence? And what are all these foundational models, right? So that we see what are these AI models. So we understood that. Now we have to loop back and ask the question, okay, fine. This GenAI model is there. And first of all, I'm not even sure why it is called as generative AI. You might be thinking, right? So why is it called generative AI? I will come to what generative AI definition is very shortly. But another question that you might be asking is, right, so, okay, this technology is fine. You gave me some use cases, but how do I think about using this generative AI technologies in my line of work? To answer that question, we have to first understand what GenAI is good at. So I already told you, GenAI is good at question answering from information sources. That is language technologies that we have, right? So this Claude models, all these models, ChatGPT models. It's very good at answering questions from information stores. With advances from our own models, multilingual language translation is possible. Indian language improving very rapidly. Speech recognition and generation, these models are very good. Text summarization and generating generic text in a grammatically accurate frame. So following instructions, writing emails, all these things, these models are good at doing. So this is what the capabilities of the model are. So now that you know what this model is capable of doing, what GenAI is capable of doing, how can you leverage that for your application? To answer that question, you have to identify if your current job has repetitive tasks that require some of the above. And currently, this might be done by a human at a slow pace. If your job has such repetitive tasks, then you have identified prime targets for AI enhanced service delivery. That is, you have to look at your current job, what all you are doing, and identify tasks in that or workflows of citizens coming to your department or your organization that you are looking at, and what all paths do these citizens go through. And along that path, are there repetitive tasks that are performed by your staff? Which is one among the following, right? So they are answering some questions, right? So they are doing some text summary, something like that is there. Then that is a prime target for AI enhanced service delivery. So let me walk you through the steps that are necessary for AI adoption. First step is to identify the current workflow of service delivery. So you map every task in the form of a flow chart and identify who does it now. ask questions like, is it manual? What information is necessary for the manual decision making? Will it help to automate the process? These questions will guide you in mapping the tasks that a current workflow of service delivery contains. This is exactly what we did in the hospital example. We mapped out the workflow of a patient walking into the hospital and exiting, what's the path that they take. In that path, we identified portions, which is doctor scribbling notes. And we thought that it would help if we automate that process, the notes get automatically generated without the doctor having to write it down. And then we understood that, okay, this looks like a speech recognition task. I told you what are the tasks, right? So let's look at what are the tasks that GenAI is good at. It is very good at speech recognition and generation. So we identified in that workflow of the patient coming in, we identified that, okay, this place where a speech recognition could help and get the text from the talk speech that was done. So we identified that and we thought that, okay, this is a very good target for me to do AI. And we did that here, there. So after identifying the current workflow of service delivery, make a list of processes that need automation. When you do that, identify the inputs and outputs of these processes, right? So what is currently done by the human sitting there and what are the inputs they use and what are the outputs they create. So let's go back to the example of the doctor-patient interaction. So currently what happens is the doctor asks some questions, the patient responds back. Based on that response, the doctor writes some notes. So input and output is the response from the patient and that is input and the output is the written text by the doctor. So now that is becomes a speech to text task. So we identify the input and output of this process and we now know that this step can be automated using GenAI technologies because I already told you that GenAI is very good at doing speech recognition and transcription. Then in each of these processes, you identify the input and output in the form of text, image, audio, and some amount of intelligent human action or thinking is necessary, then GenAI is the right tool for you. Right? So this is what we have done. You understood that? Okay. This is a speech to text problem. And usually intelligent human being thinking or action is necessary to do that activity. And so GenAI is a good tool to replace that human to do that repetitive task for you. Once you have identified the full workflow, identified the parts that could be replaced with AI to enhance the service delivery, you have to now take the help of AI developers and make that GenAI integration possible. Form these workflows to help you prepare your request for proposals, software needs, etc. Now, I am not telling that you, as administrators, have to go and develop these GenAI tools yourself. What you have to do, right? So, is to identify the tasks that can be automated through artificial intelligence, understand these things, prepare that workflow, and then use this to request for proposals for software needs to vendors. This could be software companies that are involved in digitalization processes, right? So software consultancy companies, etc. But you being aware of where GenAI can be used is very, very important for you to help prepare the request for proposals or even identify, okay, these tasks are present. So let me use AI to enhance the service delivery. So repeating, for AI adoption, digitalization is necessary. Right? So digitalization is a prerequisite for AI adoption. So if everything that is happening in your office or your line of work is completely pen and paper based, analog services, right? So in the flow chart, everything is analog, right? So no digital. Then first step is digitalization. Right? So like how can I convert that pen and paper to some digital mechanism? Imagine that currently computerization has been done, digitalization has been done, and still we are in a state where there are several repetitive tasks. Digitalization is done. Now we are ready to inject AI and enhance service delivery. In such a situation, you go ahead and identify the current workflow of service delivery, map every task in the form of a flow chart, identify who does what, ask the question, is it manual? What information is necessary for the manual decision making? And think, will it help to automate that process? Once you think that, okay, automation is possible, identify the input and output for that task. As an example, we understood that, from the speech, text has to be generated. So speech is the input, text is the output. So that process can be automated. And then always think that if the input output is in the form of text, image, audio, and some amount of intelligent human action is necessary to convert from one form to the other, then GenAI is the right tool. Sorry. Once you have identified all the possible AI enhancements in your workflow, then take the help of developers, prepare request for proposals, software needs, etc., and then go about doing that. These are the steps for AI adoption. So looping back, right? So we imagine the patient walking into a government hospital, they register at the OPD. So at this stage, we understand that currently what is done is in this step, right? So registering at the OPD, some human sits, the patient walks in, tells their name, maybe it gives their identification. The operator, one human being, is sitting there looking at that ID, typing the name in a computer, let's say, and printing out a OPD form. So there is a repetitive task where a human is sitting, looking at the ID and entering the information. So that task can now be replaced by a generative AI system. Patient walks in using their facial recognition or even Aadhaar, right? So now directly it can be entered into the OPD register. If digitalization itself is not there, then that step should have been taken place. The hospital management system has to be in place. This is why I meant AI enhancement can be done after digitalization is in place. Then they stand in line and wait to see the doctor. Of course, now also waiting is necessary, but that you can enhance the building where they are waiting with seats for sitting, etc., etc., and then they get a number and then they are called and then they go to see the doctor. Now, in the current workflow, doctor sees the patient and scribbles on the file based on the conversation they have. So it could enhance the doctor's time if that writing part is replaced by AI. An assistant to the doctor can be the AI system. Then patient goes for the investigation. So now the information what the doctor has asked must be transmitted to the lab. So that is backend IT infrastructure that is there, right? So that is the digitalization process. There is perhaps no AI that is necessary. That procedure becomes automated through digitalization itself. Then they come back to see the doctor. At this stage also AI can help. Now the AI itself can look at all the investigations, the doctor notes, etc., and then come up with some possible differential diagnosis, right? So help the doctor to quickly summarize everything and then bring it into a form that the doctor can then read and give a faster response than previously possible. So that is another step where AI can enhance the doctor's experience, the patient's experience. And then they go to the pharmacy admission as the case may be. That loop again now goes back to a digital infrastructure in place. So here we saw at least 3 places where AI can be integrated into the workflow of a digital process of the workflow and give AI enhanced service delivery, Gen AI enhanced service delivery for citizens. Another major opportunity today for artificial intelligence tools is what is called as conversation services. In the private industry, they call it as conversational commerce. This is an emerging paradigm in customer relationship, engagement, and program implementation. Right? So you have a central government scheme or a state government scheme that you want to implement. So you have to educate the public, right? So that the scheme is there. So basically, you are a salesperson, right? So if you think about it as a private industry, you have to sell a product. Now, that product that you're selling could be the Mission Indradhanush scheme. That's the product that you're selling. And your customers are all parents of young children. So, whatever the private industry is using today for enhancing customer services through conversational commerce can be applied in governance delivery also, right? So you just have to think that the product that I'm going to sell now is the product that I'm talking about, which is a government scheme, program implementation I want to do. So what conversational commerce or conversation service enables is information campaigns through natural conversation. So it combines the convenience of messaging with the traditional e-commerce services, right? So that's what conversational commerce is all about. So I will explain why it matters. So many consumers like prefer actually messaging over calling, right? So I don't want to call a company, or in this case, I don't want to come call a government office for a service that I want. I would rather just message what I need, and if I get a response from that, that's well and good. So these are a lot of consumers prefer, right? So messaging over calling, and messaging apps, right? So like WhatsApp, etc., are omnipresent, right? So they're available. 5 billion plus active users globally, right? So monthly. So like a lot of people use these messaging apps already. And for e-commerce, what is found is that sales that happens over messages are 3 to 5x compared to traditional routes for e-commerce services. So obviously, you can think about your program implementation where the sale that you're doing is the program, right? So you can get higher enrollments for that. So of course, to build this kind of application, the kind of tools that are necessary could be something like WhatsApp Business API, Facebook Messenger, Apple Business. So I'm giving some brand names over here. Of course, I'm not endorsing any of them or not endorsing the things that are not here, right? So nothing like that. Just saying that okay, these are the common platforms that are in general used for many of these applications, chatbot platforms. So you think about, right? So if there are services that you now need to communicate with the citizens in your jurisdiction, how can you leverage these messaging services if you already have campaigns that are running through traditional routes? Think about transitioning to the conversational service mode, right? So think about doing that. As an example, I will give you an example from a commercial application. So this is not a government service application that I'm going to talk to you about, because it's an emerging paradigm. Once I tell you about the commercial example, you can then think how you can leverage this kind of example in your application. So let's say there's a customer who chats with a coffee shop and then say, hey, hi, I want to order a cappuccino. Then the bot would say, okay, welcome to the company. Do you want a hot cappuccino or our Belgian chocolate version, which is trending in that region? Right? Then let's say the customer responds back saying, no, regular hot cappuccino. Then the bot can say, okay, do you want regular, oat, soy milk? The oat milk is from this particular company. It will be 60 rupees more. My customer says regular milk. Then the bot says, so do you want to come to the HSR branch for pickup? And then say, and then upsell, right? So they're saying that so far it was upselling. Now they're cross-selling. Like, do you want to add a masala cheese toast, for example? And then the customer says, no, I want to pick from this store, but I don't want any food. Then say, yeah, total is this amount. It will be ready by 145, right? So you want to pay through one of these UPI services. And then the customer says what it is, and then the GPay will be ready, and then the conversation ends. So this is an example of a consumer ordering a coffee through an app, through chat application. Now you could think that okay, the same UI, right? So user interface could have been done through a simple form filling. Yeah, it could have been, but that is considered as more unnatural and a a chat version, conversational format is seen more as friendly to the consumer. So now you think, right? So from this example, in your line of work in delivering public services, can I think of a conversational application? If so, include that as part of your request for proposals and then have a company develop this application for you. Okay. We have seen several use cases, and I have given you the workflow of how to think about which are primary targets for Gen AI enhancement to your service delivery workflow. I have done that, but even during that discussion that I have done, I have used several terminologies. Right? So I've used terminologies like generative AI, I've used platform. Some words I have used. Right? So I have even used artificial. I explained what is artificial intelligence, but I kept on using the words like Gen AI. I kept on using words like model. Right. So some of you might not know what those terms mean. So this is a common problem, right? So one major difficulty that many people face is that when they interact with AI service providers, is the terminology they use. Like I'm also an AI service provider, right? In sense, I am here to transfer the knowledge about AI that I have with you, right? So that's one service that I'm providing. So in that context, I've used several terminologies. So it is very difficult in many cases to understand, right? So what people mean. So let us actually list the different AI terminologies so that you understand these when talking to service providers and vendors that you have identified for AI enhanced public service delivery. So to identify which parts need AI enhancement, you perhaps don't need these terminologies, that you follow that workflow and understand a human is doing this task currently, and it will help if I automate it. This is the input and output, and this is a primary target for AI. I have told you, so you have understood that. Now we are discussing the terminologies that are essential for you to talk to these service providers or vendors. Because I mentioned one of the workflow items was that once you have identified the places where AI enhancement of service delivery can be done, you have to partner with the AI service provider. Right? Otherwise, how will you develop a application? So you have to talk to some digital team. It could be government's own digital team or outside vendors, whoever it is. Right? So you have to talk there, and in that conversation, you must understand some terminologies, and let's look at the different terminologies that we have. So artificial intelligence, we have understood AI. That is a computer or a computer controlled program, the ability of the computer or computer controlled program to perform tasks that are commonly associated with intelligent human beings is what we are calling as artificial intelligence. This we have understood. Now I kept using the term generative AI. So if something is generative AI, is there a non-generative part to the AI? Yes. And that is called as a predictive AI system. So in fact, AI today, narrow AI that we are talking about today, no, this is not artificial general intelligence, but narrow AI that we are talking about today can be broadly seen as a predictive AI application and a generative AI application. So predictive AI is kind of like classical machine learning applications where you want to perhaps look at a text and say whether this is a positive sentiment, a negative sentiment, a neutral sentiment. Right? So a fixed dimensional output is what you're looking at. That's like predictive AI. Right? So things like regression, classification, these are typically called as a predictive AI system. Regression means predicting a number. Classification means saying whether this is belongs to a particular category or not. As an example, if you want to predict the fair value of land parcels in a particular area, that would be a regression problem. That would be a predictive AI regression problem. You want to identify if a particular citizen is eligible to be included in a particular government scheme or not. So that is either eligible or not eligible. So that becomes a classification problem. So looking at the citizens parameters, different factors of the citizen, maybe their age, their income levels, the socioeconomic group they are coming from, all these factors, the place where they are living, Then you make a inclusion exclusion criteria, like if they are eligible for the scheme or not eligible for the scheme. So it could be a simple mechanism, simple workflow, but such problems are called as classification problems, right? So, and if you develop AI to do the classification, that's called as a predictive AI system. Generative AI is where you generate text, generate image, generate audio, generate video. These kind of applications are called as generative AI application. So in the examples that we have seen so far, in which we were generating text as output, so those are called generative AI applications. Now, the model that performs either predictive or generative is called as an AI model. So ChatGPT is a AI model for generative AI task of text generation. So that's why it is a Gen AI model. ChatGPT is a Gen AI model. As part of predictive AI, there's a whole field called as tabular data science. So tabular data science is about data is in the form of a table, and you're trying to predict features of that table given all the other information. So that's typically called as a predictive AI, tabular data science task. Then you have computer vision, natural language processing, which means giving the ability of seeing and making decisions like a human to the computer. This is computer vision. Natural language processing means using naturally spoken language by humans like English, Tamil, Malayalam, etc. Right? So those kind of languages, and processing that information is called as natural language processing. So why is it called natural language? Because in these languages, usage comes first, rules come later. As opposed to computer languages like C, C++, Python, Java, and all these languages, where rules come first, right? So usage comes later. So use is clearly defined on the basis of rules. But in the case of natural language, there are some rules, but rules came later, and there are more exceptions than rules, right? So that is why natural language processing comes into the picture. So ChatGPT, Claude 3.5 Sonnet, Gemini, these are all natural language technologies that use generative AI models. Right? So that's what they are. Another thing that you need to understand is evaluation terminology. So how do you know that your service vendor has given you a product that is acceptable for before payment can be made to the vendor, right? So for that you need to understand what are evaluation terminology. You need to understand the concept of error. Error means there's some output that is correct, and there's an output given by the model. If these two are not the same, that is the error. So let's look back to the example that we have been running of the patient visiting the government hospital. So when a patient comes and scans their ID card or scans their face, their identity needs to be mapped to the system. So if the identity mapped is, so some ground truth is there, right? So if I go and show, right, so Deepak is my identity, Deepak Subramani should come there. If the system gives something else, then the system has made an error. So the difference between what the AI system predicted and what the ground truth is, that difference is called as an error. Accuracy is the flip side of the error, right? So how correct it is, that is accuracy. Now, the problem with accuracy for classification applications, right? So that is, am I eligible for a scheme or not? That's the question. Right? So is this person eligible for the scheme or not? So ground truth, some people are eligible for the scheme, but your AI model gives you some saying that you are eligible or you are not eligible. So currently a human will sit, look at all the documents, look at all the numbers provided by the citizen, and determine whether they are eligible to be included in the scheme or not. So they have some rule based mechanism. A human is sitting and doing. Now let's say you have replaced that human with an AI system that looks through the data provided by the citizen and makes the decision of whether they should be included in the scheme or not. Okay, that's the application. So the classifier, that is the AI system, says that you should be included, Ground truth is that you should be included. That is, if a human were to do it, they would also have included them. So such citizens are true positive. In some cases, the AI model will say this citizen is eligible for the scheme, but actually they are not eligible for the scheme. So that is called as a false positive. A false negative is a situation where the citizen would have been eligible if a human looked at it and said, okay, they are eligible, but the AI system said you are not eligible. So that is called as a false negative. And the other part is true negative is that in reality that citizen is not eligible, AI system also said it's not eligible. So this green shaded portion are good. That is, the AI system is doing the correct job. Okay. So let's say there are some 100 citizens. Of that 100 citizens, 40 are eligible for the scheme, 60 are not eligible. And let's say the AI system said that 50 are eligible and 50 are not eligible. So some 10 people, right? So some 10 people were falsely given eligibility to the scheme by the AI model, right? And some other 10 people where false negative was also present. So this false positive and false negative is very important in the case of developing a classification model. And we define term called as precision. That is, what are the correct answers among all predictions that are positive? So that is called as precision. So remember it like this. Precision is related to prediction. So true positive divided by all predictions that are positive. That is precision. Recall is true positive divided by all reality positive, ground truth positive. So recall is related to reality, precision is related to prediction. In both cases, true positive is the numerator, precision and recall. And F1 score is the harmonic mean of precision and recall. So these are the numbers that you should ask for in a vendor that is developing an AI system for classification applications, right? So they are doing facial recognition and saying that this is person is supposed to be this person. Then in such cases, precision and recall is what you need to look at. So remember, precision is related to prediction, recall is related to reality, right? So among the ground truth, and F1 score is the harmonic mean of this precision and recall. So these are all evaluation mechanics, metrics that you need to be aware of when talking to AI service providers. Some other terminologies that you need are A/B testing. What is meant by A/B testing is that, so let's say currently a human is doing that activity. You're going to replace that with AI system, right? So now this replacement, how much time did it reduce in the service delivery? How many false positives got recorded? That's all this you have to see, and you have to determine whether what you did makes sense or not. That procedure is called as A/B testing. So you have to ask your client, you have to ask your service provider to perform A/B testing and prove that whatever AI model they have developed is indeed worth doing. Cloud is infrastructure that is not available on your premises. It might be somewhere geo location of the computer that run these AI models will be somewhere else, and your ability to access it from that is called cloud, and you access it through something called as application programming interface, that is called as API. Then you have to perform something called as monitoring, that is how the AI system is working in practice. All of this together is called as platform engineering, right? So you typically want a platform that will enable the AI system to be deployed for the task at hand. That is called as platform engineering. And since platform engineering is there, I also included this prompt engineering term, which is to develop these application interfaces for language technologies, how you must ask the question, right? So that is prompt engineering. So these are some deployment terminologies that you must be aware of when discussing with your clients. Finally, AI is not without issues, right? So the issues with today's AI are the same as the issues with any automation where human oversight is not present for decision making. So some of the questions that you need to ask are, did the AI model unfairly deny service to a citizen on the basis of factors that are expressly forbidden? If it did that, then that AI is unfair. So we must do everything in our power to stop that. Is the AI model worse than a human for the task at hand? Sometimes it will be, and if it is the case, right, so you have to do a cost benefit analysis. Another question is, are some citizens getting cut out due to digital divide? So digitalization is necessary for AI adoption and AI enhanced delivery. So if there is a digital divide, then that would be a impediment to AI enhanced service delivery. So before I close, and we have spoken about how AI can enhance, but remember, in many cases, the workflow for service delivery are not ready for AI. So digitalization is necessary first step. Building the database and digital infrastructure is actually a monumental task in itself. So perhaps your line of work is not yet ready for AI, then you have to go for digital first and then AI. Please think about how you can use AI, right? So that is chatbots, information retrieval, to fasten this digital adoption. Remember what we talked about AI being good at, right? So you use that to make the digital process itself run faster. Okay. With that, I close today. Thanks for attending this session on how we can use generative AI technologies for enhancing service delivery for citizens. Thank you.